Hello, good morning. Uh, Maybe I'm gonna use this microphone. Good morning, everyone. My name is Eugene. I'm from Lido and Ethereum protocol, and today I'm going to talk about V2 upgrade and from security perspective. And I'm mostly doing engineering management, so like one controversial take in the beginning of my presentation, I wouldn't talk too much about code security, about like how to write secure code, how to avoid putting vulnerabilities in your code and something like that. It's actually because of two reasons. First, because today I think that it would be a lot of very good security talk about code. And the second one, that I want to share my personal lessons learned from V2 upgrade. And my role is mostly about engineering management, code review, organizing process, and I would try to talk about things that beyond the code security. And if you're just asking me, for example, give me just one resource or article or whatever to help to get better in a code security, I would share with you only one. I guess that a lot of you know this website. It's actually the digest of biggest DeFi hacks, and we need to work hard to not get featured there. And so here is the agenda for my talk. I'm starting with a small introduction into Lido V2. After that, I would share some cases or stories around security, but not code security. I picked these stories because I think that it's, I want to share some maybe unique part of our processes, because really our goal was to make V2 upgrade as secure as possible, but it was like a lot of things that might go wrong, and our goal was to mitigate this. And like all these cases, it's really based on our experience, and challenges that we made during this V2 upgrade. And in the end of my talk, I would share you my way of thinking about protocol security as a layered cake. So yeah, I'll show you. So let's start with the stats. Lido is the largest liquid staking protocol in space. And as you can see from the stats, it's a big responsibility for the team. Like the second row, it's about code size. So even from these numbers, you can understand that it's a lot of complexity in development, and like all upgrade took 7 months of development. We have in Lido dev team something like 25 contributors. So here is how upgrade timeline look like. Two things to note. For example, things like spec, smart contract development, testnet, and security audits normally should go sequentially, right? And on this timeline, it's really more like parallel. That's happened because our goal was to try to deploy this upgrade close after Chapella hard fork, because Chapella hard fork enabled withdrawals. And our goal as a liquid staking protocol was to follow this upgrade to enable withdrawals as soon as we can for our users. So our goal was try to follow Ethereum network hard fork timeline. And the second one, it's you can see upgrade preparation stage that took a little bit more than 1 month. So like from the beginning of April till middle of May, when V2 was upgraded. I will talk about this like later in my talk. From feature perspective, V2 had 3 like epic features. This require us to completely rewrite protocol from V1. The first one, withdrawals, is the most important feature because, yeah, it's actually if you stake in a liquid staking protocol, you expect that you can unstake and withdrawals. Before Shapella hard fork, it wasn't possible, but once hard fork was enabled, and we just implement this in code. And the staking router and scaled oracles, it's a feature related to scaling and decentralizing validator set, which is very important direction for us because we're striving to, because right now we have only created set and we're striving to decentralize it. Yeah, here is to have perspective of what's the difference between V1 and V2 to understand complexity of this upgrade. Let's dive into V1 context. So it's pretty straightforward. Actually, it's a free smart contracts, Lido, Staff, Oracle, and node operators registry, and it's written using Aragon framework on top of Aragon framework. And Aragon framework was written on Solidity 0.4. And this requires us also to use Solidity 0.4, which is not great. And here is a V2 contract landscape. It's 3 times bigger in code size in a smart contract amount. Yeah, all blue contracts there is newly introduced to newly created contract, and all new contract is written on modern Solidity 0.8, and basically every single contract that you see on this slide has been upgraded except one. So it's big scope. And okay, how to upgrade Lido? Yeah, we didn't have an option to deploy V2 as a separate protocol instance, and for example, migrate liquidity after that. The only option was upgrade on a fly with one transaction, because yeah, you need to do it, you need to keep continuation of operation, right? And since the protocol is controlled by the DAO, by Lido DAO, the only Aragon voting has permissions to do that, to upgrade it. So in order to upgrade smart contracts, one needs to initiate transaction to the proxy and change implementation from old one to new one, plus some configuration, cable management, and so on. To do anything, Aragon voting has to have EVM scripts. It's an array of triplets. Who to call, which function to call, and what params to use. And you can take a look on a picture. So it's basically a list of actions that needs to be done. And if the DAO votes for this proposal, the array can be executed on behalf of Aragon voting contract. So V2 vote, it's actually EVM script plus special template contract, which we put a lot of cable management to make upgrade more verifiable. And interesting fact that executing the upgrade took about 8 million of gas, and it was front-run by Withdrawal NFT Hunter. So you can take a look on if you're interested, you can go to the link and read his blog post. So Lido V2 upgrade is a complex process, and what did we do to reduce the risk? First, I want to share our perspective how to write good spec. Good spec, from my perspective, should be first of all resilient against economical attacks, taking into account sophisticated actors, and number 3, it's very important to not try to set price on assets, but use market force to do that. Also covers all edge cases, even if it takes a lot of resources, and a good spec should be derived from first principles, starting with problem and constraints, and after that go to like solution. And yeah, so first spec, and like this story about V2, the first spec we put together for 1 week that actually described happy paths. But we quickly realized that the most problematic edge case that might happen during mass slashing, when sophisticated actors can be in better positions than regular staker, which is not good, yeah? So, and next month, we just try to mitigate in this case. So we introduced in 2 protocol modes. Turbo mode is the default one, and bunker mode for mass slashing event, which is delayed withdrawals until penalties would be socialized. Okay, so another story, it's about testing, yeah? So okay, we just did good spec, we did right code, and how to make sure that you, like, I mean, like, the code is in a development environment, right? And production environment, it's always like a little bit different from dev environment. So how to make sure that code in production performs as intended, yeah? To achieve this, we create a test suite, acceptance test suite, and we cover all scenarios and edge cases there. And next, we take the actual script that was used to upgrade the protocol and run everything in on a local managed fork of the chain to make sure that things things go in the right way. So in this environment, we run real script, simulate the voting process by impersonated accounting and voting from like our big LDO holders, and after that simulate upgrade, and after that run test suite. Acceptance test is test ensures that the protocol function as expected, but snapshot test can check that some scenarios behave the same before and after upgrade. Yeah. So, for example, staking 1F in Lido before V2 and after V2 should get in your hand exactly the same amount of staff, exactly the same amount of token, and this can be checked with snapshot tests. Okay, so you tested your protocol in a proper way, and you always need some external security. You need like another pair of eyes to check that everything is correct. So it's obvious that everyone doing like security audits, but we wanted to be sure that upgrade is correct, so we naturally wanted more than one audit, yeah? And like due to the timing, we run like these audits in parallel, and this required us to have like special coordination process. We have like dedicated person, and it was a mess. I mean, like it's wouldn't recommend do it. If you have time, just do it sequentially and just have some gaps in between of audits, yeah, because to handle all findings, you will need this time. But this helps a lot to get V2 upgrade on time, and finding sets by different auditors was different, so it was definitely worth it. And a little bit about Certora approach. Certora also did for us a security audit, but with formal verification. And on top of all these bonuses that formal verification gives you, from engineering management perspective, for me it was surprising that our developers started to think like invariant-based way. So it's like, yeah, it's like it was a surprise for me. Yeah, I see 5 minutes. Okay, so you did audit. After that, you need to make sure that you deploy it properly, right? And we have like special department in our dev team called DevOps that basically ensures two things. Ensuring that any upgrade is externally verifiable, so like all params and configuration published, and ensuring compliance with all security practices. And especially for V2 upgrade, we had like these like 4 things on top of this. The most interesting that we introduced bug bounty to not yet to be deployed code. We also had like additional audits that actually check that pre-deployed contracts and templates are matched to that version that was audited by another auditors. And yeah, we create some fun tool called DeFi. And yeah, and the last stories, it's about emergency stops. So sometimes you need to address unexpected issue, right? So for example, we cannot anticipate every scenario, yeah? And it's essential to have safety levers. And usually what people do is create kind of multisig that have permissions to do emergency stop of your protocol, right? But this introduces additional risk. So to address this, we develop like gate seal that has 3 advantages over like regular multisig. It's limited in time, so you can stop only for 6 days to allow DAO to react, and it's like one time. I guess I need 1 extra minute to wrap it up. Yeah. So protocol security, from my perspective, is a layered code, and yeah, you should always start with the code because you need to ensure that code is secure. But like you want to make sure that underlying spec is also safe. Yeah, and also you need to test it. On top of all this like snapshot tests and testing, I definitely recommend to go in a testnet, public one. You also like need to think about external security things. If you have all this underlying, you need to make sure that you deploy it in a secure way. And you always need to expect unexpected things because things might go wrong in production, and you need to address these challenges, right? And like all this stuff, it's based on people because it's actually people driving all this thing, yeah. And you need to ensure that your team is good enough. So you need to hire right people, you need to educate them, you need to build culture. And this is very important and very underrated aspect of security. And I think this is my main message to you, that security starting with people, and you need to think about it. Yeah, and that's the last slide. We're like looking for master of security to Lido team. So if you're interested or you just know like right person, just send me DM on Twitter. And please subscribe on my crypto Twitter that I recently started. So thank you.
Awesome. If there's one question, we have almost like 30 seconds. Here.
Me? Oh. So you said it's better to do sequential reviews than to have them all come in parallel. And I can see there's a trade-off there. Like when you have 2 parallel reviews, you might get different answers. When you have sequential reviews, as you said, there's a lot of benefit in being able to answer that, getting your new work checked as well as the old work. Would you do both if you had the time and money?
If I have time, I would go with a less stressed option to have it sequentially, because you can properly address all findings to like fix the protocol, get some posts to thinking about it, and after that go to next auditor. And if you do it in parallel, you need to really like apply patch, send to everyone that is working on your code right now, communicate it, and it's really, and sometimes like another auditor also found this bug and also reports these findings like with another suggestion, and it's becoming a little bit mess, you know, like it's just, but yeah, we was forced to do it because like our idea was to deploy a sub after Chapella hard fork. So I think it's not about a choice. It's yeah, it's a trade-off.
Cool. Thank you, Eugene. I think we need to stop now.
Yeah, thank you. I will be here for a whole day. You can catch me, yeah, there.